Hello, my name is Claudia Carballo. I'm a researcher in the Software Network Research Group at I2CAT Foundation, and I will present the work entitled Facilitating the Interoperable API Ecosystems of OpenCAPIF and CAMARA Integration. The summary of this presentation includes an introduction and motivation of using OpenCAPIF, few slides to showcase the functional model and architecture of CAPIF, a description of how we implemented OpenCAPIF in the context of the Spanish project CC Diferente, including a demo, and finally, the next steps. Okay, in a world where operators will expose network resources to multiple applications, this management layer comes to rescue to avoid one-to-one integration among operators, net vendors, and application developers. CAPIF is the common API framework defined by 3PP in Release 15 to manage the APIs exposed by 3PP networks in their NetBond interfaces, simplifying how developers interact with 3PP network services through a unified, standardized, and secure framework. On the other hand, in January 2024, ETSI launched the OpenCAPIF Software Development Group to further advance the development of this framework, underscoring its commitment to openness and programmability in networks. So OpenCAPIF is an open source implementation of the CAPIF core function APIs, including all the logic and additional services required to fulfill the 3PP requirements and deliver the expected functionality. As you can see in the slide, CAPIF has three main entities. The API provider, which are the entities exposing APIs. And in this case, the API provider is composed of three different functionalities: the API management function, API publishing function, and the API exposing function, which is responsible for the exposure of the service APIs, and it's the service communication entry point of the service API to the different API invokers. And in this case, the API invokers are the entities that consumes the different APIs, for example, the application providers. And the CCF, which is the cornerstone of this framework to manage the relationship between the other two entities. The CAPIF architecture has three main components: the register service, Vault, and CCF. And inside the CCF, we also have this helper service to simplify the integration with third parties. In the case of the register service, it's responsible for user management within the CAPIF ecosystem. Also, it provides a structured way for the registration, authentication, and management of the different users that interact with CAPIF. And in the case of Vault, is the certificate authority to expedite the different certificates. In the main namespace, we have this the CCF with very important capabilities like the discovery, publication, event service, invoker management service, and so on. And apart from that, there are other two entities that can use OpenCAPIF, like the admin and super admin, responsible for managing the users with the register or carry out several operations in the CCF. And also the users, they are those who want to use OpenCAPIF, registering as a user in the register and as invokers or providers in the CCF. Well, in the context of the CC Diferente project, we deployed OpenCAPIF to expose the CAMARA APIs in a standardized, secure, and unified way. So we implemented CAMARA as the API providers, and the API invokers will be the application providers to consume the APIs exposed by CAMARA. Here you can see the API implemented during the project, grouping several endpoints for the application onboarding, application instantiation, and Edge Cloud. And this is the family of Edge Cloud API to manage the lifecycle management of the different applications. Okay, at this point, we can't implement or we can show the demo. To implement this solution and to integrate the different elements, we have two prerequisites. The first of these requisites is to deploy an OpenCAPIF instance with the Vault, Register, and CCF services. In this case, we have the CAPIF services running in a virtual machine with Docker images, and we can check the status of these services running this script. And the second prerequisite is to have the OpenCAPIF SDK installed, which provides a set of libraries to enable both CAPIF provider and invoker roles, simplifying the different procedures calls. Okay, then we are ready to show the different steps, these 8 steps. From the registration of the different users, the users that will act as the providers and the users that will act as the invokers. Specifically, I'm talking about steps 1 and 4. To finally, the last step, that is the call service, where the invoker sends the request to the AEF service API. For simplicity, I have the demo recorded. I'm going to play it, and after that, I'm going to explain a little bit the next steps of this implementation. Let me start sharing my screen. And I'm going to share again. Okay, can you see my screen?
Yes.
Okay, thank you. Before starting the different steps of the demo, I would like to check that all CAPIF services are running properly. So I'm going to run this script. And as you can see, the Vault, CCF, and Register services are running. So I'm going to start with the demo. I'm going to start with the registration of a new user, and I will run this script. I'm going to proceed to explain the different steps. At the beginning, as the admin is in charge of registering the users, first of all, we are going to pass his credentials. And then if his credentials are correct, the admin user will log into OpenCAPIF. So the user will obtain a token, giving him the authorization to perform operations on the register. And with the obtained token, the admin can create and register the new user, passing mandatory fields like the username and password. And as you can see, we already created the user and we obtained the user ID. It's very important to say that this user ID, we need to store it because we are going to use it if we want to update the information of the user or we want to delete him at a certain moment. Okay, after that, we are going to perform the onboarding and publication processes. In this case, we are going to register the user as a provider into the OpenCAPIF instance, and we are going to make the publication of the services. To do that, we already prepared a JSON file with the information of the API, with the API name, and we divided the different endpoints into 3 different groups to have 3 different AEF. One with the resources corresponding to the onboarding process, another one with the resources corresponding to the instantiation of the different applications, and the last one regarding the obtention of the edge cloud zones. Okay, I'm going to run the script. And as you can see, we completed successfully all steps. We make the onboarding. We obtain the IDs of the APF, the 3 different AEF, and we made the application of the services. Here is important to say that the SDK created and stored all the necessary files for using CAPIF as provider. We have here of the authorization certificates, the certificates of the APF, AMF, and the 3 different AEF. Also, we obtain here this provider CAPIF IDs JSON file with the relevant information of this provider, and also a file containing the published API. At this point, we finish all steps with the provider, And I'm going to repeat the first step, the registration, but in this case to register the new user that will act as the invoker. I'm going to change here the user type, and let me go to the script, and also I'm going to comment and uncomment the path of the information of this user. Okay, let me run this script. And as you can see, we obtain a new user with username API Invoker 33 and a new user ID for this user that guarantee to perform different operations like update the data and also to delete the user if we want. Okay, at this point, we are going to run the next script to make the onboarding and the discovery process. We are going to register this new user as the invoker into the OpenCAPIF instance. And as you can see, the invoker was already, was onboarded and signed certificate created successfully. And also very important, the invoker could discover the service APIs successfully. Here, as we mentioned with the provider info, the SDK created this new folder with the different files containing the certificates and also containing this file with the discovered API and the relevant information, username, API invoker ID, discover services URL, register security context with the API name, API ID, and the different AF profiles with the relevant information. And also here we have the security method, the authorization method, that in this case is the security method is OAuth. Okay, at this point, we are going to, run the invoker auth to obtain the token that guarantee that the user, the invoker can consume the Discover APIs. Okay, and as you can see, we successfully obtained the access token and the security context was saved correctly because in this file we attached at the end of the file, we attached the access token. Let me show you here. Perfect. Then with this access token, then the invoker can use it to consume the different services. And the AEF must verify the integrity of the access token, verifying the CCF signature. If the validation of the access token is successful, then the AEF should verify the API invoker's invocation request and then to guarantee and grant the permission for the requested service API. Okay, for this demo, we deployed a Flask server, and I'm going to use it to check the services invocation. Here, as you can see, we have a user interface. This is the information that the invoker discovered. And as you can see, the information, the different endpoints are organized into 3 different AEF, as I mentioned before, as you can see the different IDs. And I'm going to test these endpoints regarding the onboarding part. First, I'm going to make this call, get applications. The request was successful, but in this case, we don't have any application onboarded yet. Okay, I'm going to make the post request. And as you can see, again, the request was successful and we made the onboarding of an application and we obtained its ID. I'm going to copy the ID and I'm going to obtain the specific information of this application. The request was successful again, and we have here the information of this application, containing the ID, the image path, the name, etc. And also, if I want to do that with this method, I'm going to obtain the same information. Okay, if I want to delete it, I'm paste here the information of the application ID. And as you can see, the request was also successful. So if I make again the get request, I didn't obtain any information. Okay, this is all for the demo. Many thanks. Okay, so let me comment briefly about the next steps. Okay, as a conclusion of this implementation, and also during different tests that we did, we noticed that the invoker could discover and consume all endpoints. And of course, this is not a realistic solution. So we are working on the OpenCAPIF visibility control API that we foresee to include in the next releases of OpenCAPIF to guarantee that invokers can only access and consume resources that are allowed to. For example, if we see in the diagram, the invoker 1 can consume the AF1 and the AF2, but not the AFM. And this is why we divided the API that the different endpoints in 3 different AF to guarantee that certain invokers can discover and can consume certain AF, but not other kind of AF, depending on the use case, the scenario, the type of the type of invoker, and the type of agreement between providers and invokers. Okay, many thanks. That's it from